Now, to determine whether the following signal is an energy signal, again, energy signal, power signal, or neither. And our function is expressed, or signal is expressed as such. So what we know about the signal is as follows. That first and foremost, we can evaluate the energy of such a signal, of such a discrete signal, by using this formula right here. This formula says that energy of discrete signal is the sum of all the squares of the magnitude of x of n at every point n from minus infinity to infinity. So once we know that is the equation that we are going to use, and the other conditions that we require for a signal to be energy signal or power signal, I have written them down here, whereby we say that if and only if, when I use this symbol, double F, this is that if this condition has to be if and only if these two conditions are satisfied, that is when this signal is classified as energy signal. So the first condition is energy of that signal, which you are evaluating using this formula, must be bigger than 0 and must be less than infinity, and the power of that signal must be approaching 0. The condition, if our equation satisfies this condition, then it is said to be an energy signal. And the other condition for power signal is if power is between 0 and infinity, that is bigger than 0 and less than infinity, and its energy component, or the value of the energy of this signal when evaluated approaches infinity, then we say that that signal is going to be a power signal. So we can always evaluate either of them, and if we see one of them is, for instance, if we evaluate energy and we find that it is less than infinity, we most of the times conclude that power will be 0 and this satisfies the energy signal. But it's always wise that we evaluate the full condition. So we will start with the first condition of energy signal, whereby we are saying now that we want to evaluate the energy signal, and we know our function is expressed as 0.8 to power n, and it's also a function of u of n. This is the unit step function for the sake of clarity, unit step function, and this is a delayed unit step function, and some people might get lost. So what I have simply done is to evaluate what the significance of the unit step function. So what I have simply done is that the first thing we know about unit step function is defined as follows: that it is equals to 1 for n is equals to 0 greater than or equals to 0, and it is 0 otherwise. So simply there is the equation or the signal that is characterized by the unit step is simply represented as follows. If this is our n, 0, 1, 2, 3, and this is minus 1, then we say that at the point where n is equals to 0, then we say that the function u of n is going to be equals to 1, is equals to 1, equals to 1 at these points. These are discrete step function. But it is going to be equals to 0 at any value that is less than 0. So, but then what we know is that we are talking about a slightly delayed function, and what that means is that we can try to evaluate it using replacing n with n minus 1. So I'm saying u of n minus 1 is going to be equals to 1 and 0 for n is bigger than, n minus 1 is bigger than 0. We just replace this term because previously we are saying that n is bigger than 0, but now because we have replaced n here with n minus 1, where here also we also replace this n with n minus 1. And what that does is that it allows us now to express this delayed unit step function in terms of the real value of n, and we can simply say that when you add 1 on both sides of this inequality, this says that this function will be equal to 1 when n is bigger than 1 and going to be 0 otherwise. So that now means something for us, so that if we now replace this function in our original equation, what it simply does is that this function allows us to simply change the limits of our summation. And therefore, what we are seeing, what this simply means is that this function will have values multiplied by 1 where n is equals to 1. So just the same thing we have seen here, that when n is equals to or less than or greater than 1, that is when this function will be multiplied by 1. Otherwise, it is going to be multiplying by 0, and anything that is multiplied by 0 becomes 0. Therefore, we are simply saying that the limits of summation will change from being minus infinity to being this limit that we have just found here, which is n is equals to 1. So our expression changes from having the function of u of n to only having the limits changed from minus infinity to this n is equals to 1. Therefore, now what we can now evaluate is that what will be power what will be the energy evaluated. What we have seen is that E is expressed by x n squared summation. So what we never did is simply to square our function, and if we do that, we can simply introduce our 2 there, so that our expression satisfies that of energy. And once we have done that, we can simply say that having expressed E as this, what we needed to remember is an expression, this one, this you need to remember offhand, that says that any power series expressed summed from n is equal to 0 to infinity, expressed as 8 power n, can always be written as 1 over 1 minus a, for a is less than 1. This is a known formula in mathematics, so we can just utilize this one. And therefore, since our equation is actually in that form, except this bit, so you can see very clearly that our limit is not starting at 0, and this limit is starting at 0. This one, the hours is starting at 1. So that is the only difference between these two expressions. So what we need to do is simply to express our function as this one, so that we can be able to utilize what is on the right. And therefore, what we can simply do is to express a as having being limited at 0. If we just say that n is equals to this n, let's simply say let n be equals to n minus 1. So wherever there is n, you put n minus 1 in this equation. What that will give you is that it will become n minus 1 is equal to infinity. Now I'm now working on this one. In 8 power n minus 1 is equals to sorry, this is not supposed to be infinity, it's supposed to be 0. So 0, and this is still going to remain the same thing on the right, 1 minus a on the right, for a is less than 1. So having said that, this would actually become like this one. It would actually be similar to this, because n plus 1 on both sides, it simply becomes n is equals to 1, and this remains as such. So this again means that this is equivalent to a power n over a. This a is equivalent to minus 1 here, and therefore this on the right still remains the same. So we are just manipulating our identity up here, the one that is starred, so that it can be in the form that we require, or we are modifying this equation so that it can be in a form that we can use. And what we have just seen is that now if you change this limit from being equal to 0 to be equal to 1, this is equivalent to dividing our function with a. And therefore, if that becomes the case, therefore our 0.8 squared n, you can just treat the square as 1. One function becomes 0.64. What we are now left is power n, and therefore we can simply say that sum from equals to n is equals to 1 to infinity will be equals to, it is just multiplying both sides by a and both sides by a. This a comes out and it comes here, comes there. So we are simply saying that our equation changes to take the form a to power n when n is changing from moving from being equals to 1 to infinity. Then our expression on the right becomes equals to 1a over 1 minus a for a is less than 1. Now that we have expressed our identity in the form that is similar to our equation, so that the limits are actually the same, therefore we can simply say that our a is equivalent to 0.8 squared, so that we are left with the power n alone, and therefore then we can simply identify that to be the case, as that's what I have done here. And therefore 0.8 squared over 1 minus 0.8 squared becomes 1.18, and that actually says that our energy is less than infinity. So what I have not done is to evaluate the power, but if you actually do it, you are going to find that power will be approaching 0, and therefore this satisfies the condition that we said that which is right here. How is that condition? Oh yeah, it satisfies this condition that power is approaching 0 and energy is less than infinity, and therefore this becomes energy signal. And that marks the end of our solution.